And example 3 here is what I'd like you to all do is pause the video and give this example a try. All right, so let's read this here real quick. A tower leans at an angle of about 84.7 degrees. The figure shows that 155 feet from the base of the tower, the angle of elevation to the top is 53 degrees. Find the distance to the nearest foot from the base to the top of the tower. So what we'd like to find here is this side length B. Okay. So when we go to set up our equation, let's make sure we include that side. Okay. So we have B, and I'm going to do this the opposite way. I mentioned you could do the side length over sine of the angle as well. So let's do that. B over sine of 53 is equal to, and hopefully we have a pair, an angle and a side that correspond. That way we can actually use law of sines. So it looks like we have this side length, but we seem to be missing this angle, but we can find that angle. C should just be 180 minus the other two angles. And if we subtract all these, this should give us 42.3 degrees. So now we can say, well, little c, which is 155, over sine of big C, which is 42.3, is all equal to B over sine of B. And you can see why it was actually kind of helpful to swap where we've been putting the length and the angle. Okay, right? We have sine of the angle in the denominator this time. And this is helpful because it's easier to solve for B. So this gives us B is equal to 155 sine of 53 degrees all over sine of 42.3 degrees. All right, and if we plug that in our calculators, we should get about 184 feet. All right, we have another one that I think is worth giving a try without me first. And maybe we should box our answer up here real quick. This was our final answer to example 3. But example 4, the figure shows the design for the wings of a jet fighter. The fuselage is 8 feet wide. Find the wingspan of the jet. So at first glance, they've actually highlighted for us this triangle that contains an obtuse angle, which makes us think we need to use law of sines. Okay, but it actually ends up, we can think about this problem completely in terms of right triangles. Well, if it's 170 degrees here, then the remainder must be 10 degrees. And is what we'll do is here I'm going to sketch in the base of the triangle I'm thinking of. And we'll come straight down this way. And we can actually compute what h is here. Okay. And if we can find h, well then we know we have that exact same side length over here. Right? We hope these airplane wings are the same length. This is also h, this is also 10. And this should also be 32 feet. But the point is now we could just do h plus the 8 feet plus another h. And that should give us the wingspan. And actually, let's start off with a trig function. So if we're looking at this h and the 32, That's opposite over hypotenuse. So sine of 10 degrees is equal to opposite over hypotenuse, which means that h is just really equal to 32 sine of 10 degrees. And we don't actually really need to compute what this is right now, because all we care about in the end here is, well, what is that h plus 8 plus h? That's what we want to compute. If we add all those together, we should get about 19.11 feet. And one thing I would like to say here is that this question didn't say what place to round to. I just chose to round to the nearest hundredth here. That's it for that one. We didn't actually need law of sines.